Polynomials. Today we'll talk about addition and subtraction. You'll find this is a fairly easy section. Isn't that nice once in a while? What else can I say about it? Well, we've already done the definition of a polynomial, and that's going to be important to us. We're going to add polynomials, find the additive inverse. Basically, what does that mean? We're going to, if we have, for example, a positive x, the additive inverse is a negative x. If we have a positive 1/2, oops, if we have a positive 1/2 y, the additive inverse would be a negative 1/2 y. And we're going to use this additive inverse in subtraction to show you how actually we don't even need subtraction. All we need to do are additive inverses. Addition and subtraction of polynomials. Here's our little 5-minute review. We have a polynomial with an input. Remember, this is not multiplication. This is just the name of our polynomial, which is p, and its input, which in this rendition of it is x. Well, suppose instead of putting in x, we decided we're going to put in, here's our input, we're going to put in a -1. So then I'm going to get a new rendition without x. It's going to have a -1 where x used to be, and of course, what do we do to that input? We square it, and then we subtract 9 times that input. Let's make sure those don't look like 7s. And add 4. So that's easy enough to do. Please, please, please remember, when you square a negative, thank you, yes, it becomes positive. This one, our input in the original rendition, and this is typical, isn't it? When you first see a function, or let's say a polynomial here, the first rendition of it is usually with x or some other variable. But oftentimes, its usefulness to us is at a particular value. So in this case, we're going to put in 2. So we're going to cube that input, 2. We are going to subtract the square of that input, 2. We're going to add 1 of that input, 2. And then subtract just a plain old 1. Collect like terms. Okay, let's see if we have any that are like. What do we have to have? We have to have, in each term, to match, it has to have the same variables at the same power. Exactly the same. Okay, so we've got x to the third and y. Well, this one, right? These match, x to the third and y. So those two can be combined. Then we've got x to the first, y to the fourth. All right, so these two can be combined. And when I do that, I've got +2 of this critter, +5 of that, so that gives me 7. +4 and a +1, right? We know there's a 1 there. We just don't bother to write it out. It would take imagine if we wrote all those 1s out. What a waste of time. So we usually have some version of things that has a default, which doesn't require you to write the whole thing out. A coefficient of 1 is an example of that. An exponent of 1 is another example of that. Addition and subtraction of polynomials. Just a quick review here of what a polynomial is. It is a variable raised to a power, which may have other terms added to it, which are very similar. What are the differences? The differences are in the coefficients. The coefficients may vary, or they may be the same, right? But that's totally free. You can have any constant you want here as a coefficient, and there's one for each power term. Your highest power is at the beginning. Your lowest power, and your lowest power is always x to the 0. And we know x to the 0 power. So here's where you find your constant term. Here's an example of that. Here's another example. That's the end of our examples of this particular term. This one it has an n, the highest power of 3. Its coefficient, a to the n, is 2. This also has power of 3. Oh, yes. So these match. And this matches. So we can combine with addition. Let's set this up in columns. Plus 4x plus 1, just like we did back in grade school. Of course, this is a plus. If we wanted to put something in this column, that would be a plus 0, wouldn't it? So we add those up, and we get 8 of these x cubed, 7 of a plain old x to the first power, and for our constant terms, just a 1. How about this one? One of these has 4, and this one only has 3. We know we're not going to match everything. So we've got, I'm actually going to rewrite this one. There's a reason why I'm going to do that. Oh, okay. Sometimes you catch me having to do some of my technical work here in front of you. I'm going to move this down a little bit, give us a little more room, because I want to rewrite this, and I'll show you why. I want to put the 4th powers of x there, the 3rd powers of x. See how I'm doing the descending powers. Now I don't have x to the 2nd in this one, but because I do in here, I'm going to leave a space for it. And I'm going to go from, okay, 4, 3, 2, which I don't have here, to a power of 1, to a power of, thank you, 0. This one I'm going to line up underneath it, 4, x to the 4th. And I don't have a power of 3 here, but I do have this one we've been looking at, and a plus 1. So what I've done, I have organized these as I set up my addition. And of course I've got 7 of these. Now we can get some very long polynomials as we start adding polynomials that have unlike terms, because they each carry themselves independently of the others. So our answer turns out to have how many terms? 1, 2, 3, 4, 5. All right, how about this one? This is a match. This is a match. This is a match. And this is a match. And then these two are a match. I'm not going to line these up this time just to save a little time, but I'm going to say I've got 2 and 4. I add those up, I get 6 x squared y cubed. I've got 4 of the plain old xy and 3 of them over here, so that's 7 of my xy's. Then I've got xy squared, 3 plus 8. What am I saying? 3 plus 5 is 8. My mind goes ahead of my mouth. Okay. Is it possible to add 2 polynomials that have no like terms? Well, consider 2 that have no like terms. Suppose I had x cubed plus x squared, and I wanted to add x plus 1. Yes, I can add those. I just have to think about it. I don't have to write this, by the way. I'm just doing it for conceptual purposes. I just have to add in where the zeros are, and then those will add up perfectly. Suppose I have a 2-term polynomial and a 3-term polynomial. I'm adding them together. What's the maximum number of terms that I could have in my sum? Well, if I have no like terms between these two, that's right, 5. What's the minimum number of terms that can be in a sum? Well, of course, we're talking about sum of polynomials. What's the minimum number you could have? Well, suppose I was adding this polynomial, x3, and this polynomial, x to the 3rd power. My sum, so that would be 1. Now, maybe that's not really the question I want to consider here. Maybe what I should have been thinking about is what's the minimum number of terms that I could have in the sum of a 2-term and a 3-term polynomial. The assumption here is that these polynomials are already in good polynomial form, so they don't have any like terms in common within the polynomial. But these 2 terms could be matching to two of these, and in that case my answer would be 3. By definition, a polynomial consists only of sums. Remember that subtraction is the addition of the additive inverse. Oh yes, that can be very helpful. Particularly, think about how useful it may be if subtracting negatives tend to get into trouble for you. I know they do for me. I would much rather simply do this, or be able to always keep my mind thinking of addition. This way we don't even have to ever worry about subtraction. We're going to subtract this polynomial, so this is what we're going to subtract, right, from this polynomial. So we put this first, and then we subtract. All right. But suppose I want to do it by adding the additive inverse. What I would do in that case, I would figure out what the additive inverse was by changing every sign in the term. This 7 is positive, I make it negative. This 6 is negative, I make it positive. negative, positive, positive, negative. So now this is the additive inverse of this one. What does that mean? That means I can just add them together. Plus, add. I like adding. So I line them up so that the variables and powers exactly match, and I have my answer. Find the additive inverse of this. What do? The additive inverse, we just reverse the signs of every term. Becomes negative 5x squared y, negative 2xy to the fourth, negative 7. There's my additive inverse. Find the additive inverse of this one. So I reverse the signs. It gives me a 3xy positive. This one becomes negative. And of course, my last one, change that sign. So it's a pretty straightforward concept, additive inverse. Mentally subtract this from this. All right. I'm mentally checking to make sure that I've got like terms. So I'm going to subtract this from this. So 3 from 7 leaves me with a positive. Subtract 4 from 6. I could do that in my head, of course. So can you. Now, let's subtract it. I got the same. Now we got a different problem. I'm going to subtract this, and I'm going to do it by converting from subtracting this polynomial to adding. What is it called again? The additive inverse. It's funny how you think about addition and subtraction of polynomials, how simple that is, but some of these concepts might be new or we haven't seen them in a while. So this positive 2 inside the parentheses, remember it is positive, becomes a negative 2, positive 4 becomes a negative 4. And the negative and then I can simply add these together. All right, see you back in class.